Okay, for this problem we have a scenario. We have a box with white balls and black balls, and we're going to draw them one at a time until B black balls have been drawn. So let X be the number of draws that it takes until B black balls have been drawn. For problem 7, the question is, what is the distribution of X if the draws are made with replacement independently? So for problem number 7, so let me write out the definition of the random variable first. Let X be the draw number of the Bth black ball. For problem number 7, X is going to have one of our standard distributions. It'll be negative binomial. The reason it is negative binomial is because we're doing something independently over and over again, and we're waiting until the Bth success. So we're waiting for the Bth success, and the chance of success would be B divided by the total number of balls, W plus B. And so this is one way of specifying a distribution by just identifying it as one of our standard distributions that we've discussed in class. Now, for problem number 8, it's a little bit more interesting. The draws are now without replacement. This one does not fit one of our standard distributions. So what we have to do is find the possible outcomes and then the probability of each one. So let's figure out the probability that X is equal to n. What's the chance that the Bth success occurs on the nth draw? Now, if I'm drawing without replacement, that's basically saying how long does it take until all black balls have been pulled? Well, in order to pull the last black ball on the nth draw, that means on the first n minus 1 draws, I have to pull out B minus 1 black balls. So B minus 1 black balls chosen in the first n minus 1 draws. So that has to happen first. Then I multiply by the probability that the nth draw is the last black ball, given that I've already pulled out B minus 1 black balls in the first n minus 1 draws. Alright, now this first probability here is hypergeometric. There are B black balls in the box. I want to choose B minus 1 of them. There are W white balls in the box, and I want to choose n minus 1 minus B minus 1 of those. And in total, there are B plus W balls in the box, and I'm choosing n minus 1 balls total. So that's the first probability, is this, using the hypergeometric distribution, counting the number of successes when drawing without replacement. Finally, the second probability, the chance that the nth draw is black, given that this has been pulled out. So if I've already done this, then there is only one black ball left in the box, and the total number of balls left is B plus W. That's the total number of balls, and we've already selected out n minus 1 of them. Okay, now this can be simplified somewhat, but not a whole lot. B choose B minus 1 is B if you work out the factorials, and this becomes W choose n minus B over B plus W choose n minus 1. Then we multiply by 1 over B plus W minus n plus 1. And so that's the probabilities. Now, what are the possible values for n? Well, n has to be at least equal to B. There are B black balls in the box, and so it requires at least B draws in order to pull them all out. And the most that n can be is the total number of balls in the box, B plus W. And so here I have the probabilities, and so that these are the possible outcomes. N can be somewhere between B and B plus W, and I've got the probabilities for each of them.